In today's class, we will try to learn about motion. Before starting that motion, let's try to see what are the contents to be taught today. First, we would like to learn about some introductory part of motion. Then we will go to motion along a straight line, types of motion, and acceleration for today. Got it? But this graphical representation, derivation of equation of motion, uniform circular motion, this will be done in the next class, right? Yes, let's see. Now in our day-to-day life, we see many objects moving and some of the objects not moving. So those objects which doesn't changes its position with respect to the surrounding, with respect to time, that we call it that object as in rest. And those object which changes its position with respect to the surrounding and with respect to the time, we call it that as what? Motion. So just to say that the object is in motion, the object should change its position with respect to the surrounding with the passage of time. Got it? So car plying on the road, a train moving along a railway track, a man walking on the road, all these are the example of motion. Okay, all these are the example of motion. A body is said to be at rest, as I said, if it doesn't changes its position with respect to its surrounding with the passage of time. So this with the passage of time is also very important. A book placed on the table remains on the table, and we say that the book is at rest. Although the study of object at rest is important, a large part of our everyday experience concerns the things that move. For this reason, the study of motion is one of the basic studies in physics. In this chapter, we shall discuss the fundamental aspect of motion. Now let's see the motion along a straight line. Now motion along a straight line, this is the simplest type of motion. Okay, and this simplest type of motion, we call it this as rectilinear motion. That means those motion along a straight line, we call it as rectilinear motion. Now to understand more, let's try to take the help of an example along with a diagram. Okay, consider an object, okay, moving along a straight line, that means from left to right, and this mark 0 kilometer is the starting point, which will be denoted by O, and every segment is of 5 kilometer. Okay, but it is not in a scale. Don't think that Kolkata is only 25 kilometer. Don't think that from Kolkata to Chennai it is only of 10 kilometer. Don't think not in that way. Okay, this is not as per the scale. So this is just for the sake of what studying only. You think it in that way. Now let the object start from O. Okay, from this O, this is a starting position. Here it is marked as O. So this O is situated here, and the object moves along this path, reaching this Kolkata, which is a 25 kilometer, then to Chennai, then to Delhi. Okay, the object reaches Delhi here. Now without stopping, it is not the final position. It comes from this starting point O and it reaches this Delhi, and it returns back again up to Kolkata, passing through what? This Chennai. So this starting point, we call it as initial point, and the final point, we call it as simply as final position or terminal position. So let's take it these as a final position. Got it? So initial position, final position. Now in the next part we will learn about what distance covered and displacement and their differences. Okay, so this distance covered, sometimes it is also known as path length. What is this path length or distance covered? The path length or distance covered by the object, it is the total distance moved by the object from the initial position to the final position. That means from initial position to final position means the path length means in between initial and the final position. That will be much more appropriate. Okay, so the path length will be what? It's starting from here, that means from the O, and then it reaches this Delhi, which is at 60 kilometer. So 60 kilometer is the path length now, and then it has to move from 60 Delhi to Kolkata, right? So what is the length between this Delhi and Kolkata? In returning back here like this, 60 minus 25 is 35, right? So the total path length will be 60 plus 35, that will be equal to 95. So your total path length will be the total length of the path moved by the object from the initial position to the final position. Got it? This is a scalar quantity. There is no direction at all in the case of distance. But in the displacement, we need to take this initial and the final here. So what happened? The displacement is the shortest distance drawn from initial to final. Not from final to initial. It should be from initial to final. So its displacement will be a vector quantity. It has a direction from initial to final, and its magnitude will be what? From here to Kolkata, it is what? 25. So 25 kilometer from initial to final, that will be known as what? Displacement. Let's see. In the next slide you will see. Okay, so path length, the total distance or length covered by a body between initial and the final position, we call it as what? Path length. Got it? As I said in the above, that means in the previous diagram, I should say, the total path length covered by the object is what? OD. That means O is the initial position, D is Delhi, then plus Delhi to Kolkata. So OD is 60 and Kolkata is at 25. So 60 minus 25 will be what? 35. So the length of the path moved from Delhi to Kolkata is what? 35 kilometer. So 60 plus 35 is 95. It is said to be the distance covered by the given object. Okay, so what are the characteristics, what properties are possessed by this path length? It is a scalar quantity. It has no direction at all. It has only magnitude, no direction. Got it? The magnitude of the path length is always positive. It can never be negative. Got it? Magnitude of the path length can never be also equal to 0. If the body doesn't move, that is a different thing. If the body moves, okay, then what happened? Its magnitude, that means the magnitude of the distance covered or path length, that can never be equal to 0. Got it? Yes. Next, displacement. The shortest distance measured from the initial position to the final position of an object is known as displacement. In short, you can say the shortest distance drawn from the initial to the final position. Got it? That is known as displacement. It is a vector quantity. If it is a vector quantity, then what happens? It will have its magnitude as well as what? Direction, right? It will have its own magnitude as well as direction. Got it? Vector quantity. If it is a vector quantity, it will surely have magnitude and direction. So for that example, in that one, what happened? O is the initial position which is marked at 0, and your Kolkata is the final position, which is marked at 25, right? What 25 kilometer, right? So what happened? This is the initial position and Kolkata is the final position. So from initial position to final position, if you draw a shortest line, that means a straight line joining this origin, or rather O and the Kolkata, then that line with an arrowhead starting from where to where, from the initial to the final. So the magnitude will be what? 25 kilometer. The length of this 0 to 25, that will be 25 kilometer, and the direction will be from what? Your starting point to Kolkata. Got it? Yes. Now let's see type of motion. How do you think? How many types of motions are there? Yes, there are two, right? The first one is what? Uniform motion. The second one is non-uniform motion. What is meant by uniform motion? Uni means one, form means state. You all are wearing uniform in school, no? So it has same color, irrespective of sex, whether it is boy or girl. All you will wear what? Blue, black, okay? Pant, shirt, right? But in the shirt it will be what? White, gray check, okay? White with your blue lines. That means you can say check. Got it? Check shirts, right? In that way. And you must be wearing what? Black shoe, right? So shoe color must be all same. Uni means one, same means one, okay? So uniform means what? It will be of same, equal, constant, we can say. So those motion which what? Move equal distance at equal interval of time, this type of motion are known as uniform motion. So uniform, uni means one, that means what happened? Uni means one, means equal. Equal, if it is equal, that means it will be same, only one. Equal distance in equal interval of time, that equal are same, right? So in equal interval of time, if the body travel equal distance, then we said that type of motion as uniform motion. I will show you the diagram, the motion of a car here, okay? In that car also, suppose you see the speed of the car remains constant, same, you see. Got it? You see again. Got it? Yes. So such type of motion which moves with a constant speed, you can also call it. Constant speed means what? Speed means distance divided by time. So that means distance traveled per unit time will remain constant. For every second, if the body moves 1 centimeter, for example, then we call it that speed of the object as 1 centimeter per second, right? So for every second, 1 centimeter distance will have to move. Got it? So that type of motion is known as uniform motion. If you are going to represent by this distance time graph, then what happened? For every 1 second, okay, somewhere here, for every 1 second, the distance move will be this much. If you take it somewhere here, again 2 seconds, the distance move will be again 2 centimeter again. If you take it somewhere here, 3 seconds, the distance move will be again 3. Got it? 1 plus 2 plus 1 will be 3, like that. So what happened, as time increases, what happened? The distance move will be also keep on increasing. Got it? Yes. Let's see for the second slide for non-uniform motion. Okay, this is for non-uniform motion. See, it moves, it starts. The car doesn't move with a uniform speed. It moves very slow. Sometimes it stops again, it takes up again its speed, like that. So such type of motion we call it as non-uniform motion. So for that type of motion which is of non-uniform motion, then what happen? The distance traveled in a unit time will not remain same. At some time, what happen? The distance move will be very much short. As the speed is more from somewhere to here, what happen? The speed will be more, so distance covered will be more, like that. Okay, so the distance covered per unit time, if they are different, then that type of motion we call it as what? Non-uniform motion. In short, we can say that if unequal distance, okay, covered by the object or traveled by the object during what? Equal interval of time, then that type of motion is known as non-uniform. In that previous example, similar to that, for every 1 second, if the body doesn't move equal distance, okay, for example, in the first 1 second, if the body moves 1 centimeter, okay, and in the next second, what happened? If the body moves 2 centimeter, in the next second, that means in the third second, if the object moves say 5 centimeter, likewise, if it keeps on increasing the distance covered during that equal interval of time, if they are not same, then that type of motion is known as non-uniform motion. I will show you that picture of the this car. You just look very carefully, okay. It will not move smoothly with the same distance traveled per unit time. Rather, it will have to move slowly like this, then it will speed up, then it will move like that. Got it? You just see. Clear? Yes, such type of motion is known as what? Non-uniform motion. And if you want to represent this type of motion with the help of distance time graph, then it will not be a straight line passing through origin. Rather, it may be curved upward like this, or it may be little bit moving like this, or it may be, if it is not straight line, then you must conclude that this distance time graph is not a uniform motion. It may be what? It may be of this like this, the graph may be of this like this, it may be in this way, and then it may be in this way, or it may be like this. If it is not curved, it may be in this way also, who knows. So these are all curved, not straight line, right? So such type of graph we will call it as what? Representing what? Non-uniform motion. You should not think that only this type of graph is for representing non-uniform. It may be of that zigzag, it may be of curved downward, it may be little bit curved like this, and it may be going like this, and it may be straight in this way. So such type which is not actually a straight line passing through origin, these type of graphs will represent what? Non-uniform motion. Okay? Yes. Yes, next let's try to learn about acceleration. Okay, now if the object is not moving with the same what? Speed, then we will call it that type of motion as what? Having some acceleration. If the body is moving with the same speed, then we will say that the acceleration of that object is 0. We know during uniform motion of an object along a straight line, the velocity with time, okay, the straight line, the velocity with respect to time remains constant. In this case, the change in velocity of the object for any time interval is 0. In the case of uniform motion, I told you that equal distance move in equal interval of time. That means the speed. How do we define speed? Speed may be defined as what? Distance divided by time, right? Distance divided by time. So if you are going to represent what speed, let me write here, speed is equal to what? Distance divided by time. So in the numerator it will be what? Distance let me represent like this. Okay, I can't write nicely here with my mouse. Distance divided by time. Got it? So distance divided by time, we call it as speed. So if the distance move in 1 second, so this will be 1 second, and distance will be also 1 centimeter, for example. So 1 means what? It will be equal to 1. In the next second also, the time duration will be 1 second. It covers 1 centimeter. So again 1 centimeter per second. So what happens? Speed will remain same. So if it is of same speed, if the object moves with the same speed, that means distance travel equal distance move during equal interval of time. We call it as what? Uniform motion. You can also say that uniform motion in a very short definition, that an object moving with equal speed, constant speed, same speed, we call it that motion as uniform motion. For those of object moving with uniform motion, what happen? Its acceleration will be equal to 0. This speed means what? It doesn't have any direction. Okay, it may be along at any direction, but in the case of acceleration, we have to define it in terms of what? Velocity. When we say velocity, then this speed should be in a particular direction. Okay, so if the body moves with the same speed in a particular direction, then what happen? Its velocity will be also constant. Direction doesn't change, speed remains same. So what happen? We can say that what? Velocity also with a remain with the same velocity. The object moves with the same velocity. Okay, so if the object moves with the same velocity along a straight line, then what happen? Its acceleration will be 0. But if this velocity changes with time, then we will talk about acceleration. Then what is this acceleration? When the velocity changes, okay, velocity changes during its path along its straight line. If the velocity changes, then the question arises about that of acceleration. What is this acceleration? Actually, acceleration is defined as the rate of change of velocity. Got it? The definition, the formula is given here. Acceleration is equal to change in velocity divided by time. I told you that in physics, if the denominator is time taken, then we will define as a rate. If time is there, then what happens? We will have to define it in terms of what? Rate. R-A-T-E, rate. So what happened? Rate of change in velocity, we call it that as acceleration. That means in 1 second, if the velocity changes, then how much the velocity changes during that 1 second. Okay, we call it that as acceleration. So rate of change of velocity, okay, is known as acceleration. Rate of change of velocity or rate of change in velocity, whichever you like it, you can say. Okay, so if the velocity changes, then how much the velocity changes in 1 second, we call it that as rate of change in velocity. Okay, and it is known as what? Acceleration. Now let's see. If the velocity of an object changes from an initial position u to the final position v in time t, then acceleration is denoted by a. Okay, u represents what? Initial velocity, small v represent final velocity, then acceleration a is defined as what? Change in velocity. Change in velocity will be what? Final velocity minus initial velocity divided by time taken, duration of time. Okay, to change the velocity of the body from u to v, it takes the time small t. That is the meaning. I'm telling you again, to change its velocity from u to small v, final velocity, the time taken by the body or object is this small t. Suppose if the object is moving with 3 centimeter per second, and with the what? Passage of time, if the what? Velocity changes to v, and the time to change from this 3 centimeter per second to, let's take it as 5 centimeter per second, this final velocity, it takes what, 2 seconds for example. Okay, from 3 centimeter per second to 5 centimeter per second, it keep on increasing, and it comes to 5 centimeter per second. It was previously what, 3 centimeter per second. Now it keep on increasing, and from 3 we have reached that 5 centimeter per second during a time duration of what, let's take it as 2 seconds. Got it? Then your acceleration will be what, this is 5, u is 3, so 5 minus 3 divided by time duration is 2, so 2 by 2 is what, 1, so 1 centimeter per second square. Got it? Yes, SI unit will be 1 centimeter per the acceleration for this one is what, centimeter per second square, because we have taken this velocity as centimeter per second, but in SI unit it is not centimeter, rather it will be meter. This will be, let's take it in the SI unit, that this velocity, initial velocity of the body at the very beginning, initial means, let's take it that this is moving with say 3 meter per second, and it goes, okay, with the passage of time it reaches to 5 meter per second. In the duration of time from here to, from 3 meter per second to reach up to 5 meter per second, it takes, so let's take it as 2 seconds. So 5 minus 3 divided by 2 seconds, that will be what, 5 minus 3, that means 2 meter per second divided by 1 second again. So in total it will be what, 2 meter per second square. Okay, that is the SI unit here. Okay, and now let's see, this acceleration is a vector quantity. So acceleration is a vector quantity. If it is a vector quantity, then what happen, it should have both magnitude as well as what, direction, right? So you better write these as with a vector quantity. A, this is also vector quantity, velocity is also vector quantity, u is also a vector quantity, so we should put an arrowhead like this. Okay, and what happened, this acceleration, if it is what, acceleration is a vector quantity, then it will have magnitude as well as direction. So the direction of this acceleration will be along the direction in which the change in velocity takes place. Got it? Got it? And if the change in velocity is in opposite direction, then we will have to take it as negative. Got it? If the change in velocity, okay, is in the direction of that what, change in velocity, then acceleration will be taken as positive. In short, you can think of very easily, not in this way. Suppose if this final velocity is greater than the initial velocity, then it will be what, positive. If your v, okay, if your v is greater than what, u, then your acceleration a is what, positive. Mouse is not working well. Okay, is positive. And if your v is less than u, then what happen, your acceleration will be what, negative. Got it? And let's see how this SI unit is coming to this meter per second square. I'm giving you here, say v, the difference in velocity will be what, velocity, 5 meter per second minus 3 meter per second will be what, 2 meter per second. So the difference of velocity will remain as velocity, and the time duration in that previous example as I cited, it will be what, 2 seconds. So it will be 2 seconds. Got it? Now let's talk about this unit. Okay, not that numerical value, rather for this unit. So in the numerator it is meter per second, in the denominator it is second. So meter divided by second, that is known as meter per second. In the denominator again 1 second is also there, so into second. So what happened? Meter divided by second square, we call it as meter per second square. Meter per second square. You can write, if you want to bring this in the numerator, then power minus 2 is there. So we read these as meter per second square, or we can read these as meter second inverse 2. We can read that in that way also, but it is better to read as meter per second square. Okay, that will be better, right? Okay, up to this we will do, and in the next class we will try to see the remaining portion, that is what graphical representation and those of what equation of motion we will do later on. Okay.